In this lecture, we have learned the hardness of water. That water contains the hardness due to presence of some amount of salt into the water that causes that hard water or soft water. That water contains the hardness due to presence of calcium and magnesium ions into the water. If water contains the hardness, that water cannot form the leather readily with the soap, because that calcium and magnesium ions get reacted with the soap and it forms the calcium stearate and sodium carbonate atoms. That's why the slump formation takes place with this calcium and this soap solution. That hardness can be categorized as a temporary hardness or permanent hardness. The material consists of the temporary hardness due to presence of the carbonate hardness. Means if the calcium and magnesium atoms present with the carbonates or the bicarbonates, that terms as a temporary hardness. This temporary hardness can be removed easily with the boiling process. If we take the calcium and magnesium atoms, we boiled it, that get converted into magnesium hydroxide, calcium carbonate or the magnesium hydroxide. These are the dissolved type of impurities that are precipitated at this bottom of this solvent, and we can remove the hardness from this boiling process. The permanent hardness, water contains the permanent hardness due to non-carbonate hardness. A material consists of calcium and magnesium is present without the calcium carbonate or bicarbonate. It is also called as the non-carbonate hardness. That non-carbonate hardness cannot be removed by the simple boiling process is called as the permanent hardness. That water containing that type of hardness is also called as a non-carbonate hardness or non-alkaline hardness. The total hardness of water sample get analyzed with the formula temporary hardness plus permanent hardness. The hardness can be determined with the EDTA method. This EDTA method is complexometric titration. We require the buffer solution about the 10 pH for this experiment, and that EDTA get reacted quickly with the hardness causing metal ions even at a very low concentration. Here we use the indicator as a Erichrome black tea as an indicator for this experiment. That metal get reacted with the EDTA, that's forming the complex as a metal EDTA complex as shown in the figure. In this experiment, we will use as the EBT as an indicator. That EBT having the bluish in color. When that metal, that EBT get reacted with a metal, it forms as a metal EBT complex, and that metal EBT complex is having the pink red in color. Excess amount of EDTA when we add into this solution, that will be formed as a metal EDTA complex. That metal EBT complex is not that much of strong. If we add the excess amount of EDTA into the same solution, it forms as a metal EDTA complex, and that EBT get regenerated in the solution with bluish in color. That's the end of this experiment. The total hardness can be determined with the using of formula total hardness is equal to V1 into M into 100 into 1000 upon V with the calcium carbonate equivalent, where V1 is a burette reading, V is a volume of hardness causing sample is taken into the titration, M is the exact amount of molarity of EDTA. The permanent hardness of water sample can be determined with the V2 into M into 100 divided by multiplied by 1000 divided by V with the calcium carbonate equivalent, where V2 is a burette reading of a boiling water sample, V is the volume of water sample is taken for the titration, and M is the exact molarity of EDTA. The temporary hardness can be analyzed from this formula, the total hardness minus permanent hardness.